Dear students, welcome to the Karnataka Learning Management System. Myself, Suguna, Assistant Professor, Department of Mathematics, working at GFGC and PG Center, Chintamani. In this video, I am going to present you polar coordinates and angle between the radius vector and the tangent. Polar coordinates. In the figure, let O be a fixed point and it is called a pole or origin. Then OX be a fixed line through O and we call it as initial line. So OX is a initial line and O be a pole. So OX be a fixed line through O and it is also called as initial line. Initial line means it is nothing but x-axis. Then OP. P is any point in this plane and a line joining OP is called as radius vector and that is denoted by R. So R is a radius vector. Then the angle between POM means the angle between the radius vector and the initial line is equal to theta. That is called as the vectorial angle and XOP is denoted by angle theta. And the point P is recognized by the coordinates R and theta. So these coordinates are called polar coordinates. So P is denoted by R and theta. Those R and theta are called the polar coordinates. From the figure, O is a fixed point that is called as a pole or origin and OX is initial line. Then OP is the radius vector of the point P and which is denoted by R. The angle between the radius vector and initial line is denoted by T, that is called as vectorial angle. XOP is called a vectorial angle. Then P is represented by coordinates R and theta. Those R and theta are called polar coordinates of the point P. Now let us see the relation between the Cartesian and polar coordinates. X and Y are the Cartesian coordinates of a point P. Then x is equal to r cos theta and y is equal to r sin theta. This relation gives the Cartesian coordinates in terms of polar coordinates. See, x and y are Cartesian coordinates, r and theta are polar coordinates. So x is equal to r cos theta, y is equal to r sin theta gives the relation between the Cartesian coordinates in terms of polar coordinates. Then r is equal to root of x square plus y square and theta is equal to tan inverse of y. This gives the relation between the polar coordinates in terms of Cartesian coordinates. These relations we get by squaring x is equal to r cos theta and y is equal to r sin theta and add we get x square plus y square is equal to r square cos square theta plus r square sin square theta. By taking the square root, we get r is equal to root of x square plus y square. Then to get theta, divide y by x. Then we get r sin theta by r cos theta. R get cancels. Sin theta by cos theta is equal to tan theta. Tan theta is equal to y by x. Therefore, theta is equal to tan inverse of y by x. These two equations give us the polar coordinates in terms of Cartesian coordinates. So, by using these four relations, we can convert the Cartesian coordinates into polar and polar into Cartesian coordinates. An equation of the curve in a polar form is represented as r is equal to f of theta. See, r is equal to f of theta is the polar curve. The relation between Cartesian and polar is x is equal to r cos theta, y is equal to r sin theta, and the polar coordinates in terms of Cartesian are r is equal to root of x square plus y square, theta is equal to tan inverse of y by x. Now let us derive an important formula to find the angle between the radius vector and the tangent at a point on the curve. Consider the figure. Here O is a fixed point and we have OX initial line, and r is equal to f of theta is a polar curve, and P is a point on it with the coordinates r comma theta. OP is the radius vector r, and which makes an angle theta with the initial axis x, and phi is the angle between the radius vector and the tangent. See, T is the tangent drawn to the initial axis from the point P. So phi is the angle between the radius vector and the tangent. Let x comma y be the Cartesian coordinates of the point P. Thus we have x is equal to r cos theta and y is equal to r sin theta. We know that the polar curve is denoted by r is equal to f of theta. Then which implies that x is equal to, in the place of r we substitute f of theta. So x is equal to f of theta cos theta, and y is equal to r sin theta means y is equal to f of theta sin theta. Now let us differentiate these two equations with respect to theta. So we get dx by d theta is equal to minus f of theta into sin theta plus f dash of theta into cos theta. See, x is equal to f of theta into cos theta. Here we made use of the product rule. So f of theta keep as it is. Derivative of cos theta is minus sin theta, plus derivative of f of theta is f dash of theta, and keep cos theta as it is and take this as equation 1. Similarly, the second equation, y is equal to f of theta into sin theta. Then the derivative of this with respect to theta is equal to dy by d theta, which is equal to f of theta into cos theta plus f dash of theta into sin theta. Let us take this as equation 2. Now we know that the slope dy by dx is the slope of the tangent pt. dy by dx is equal to slope of the tangent pt, see, which is nothing but tan psi. The slope of this tangent is tan psi. So dy by dx is written as dy by d theta by dx by d theta, and tan psi. See, psi is the exterior angle of the triangle OTP. So the exterior angle of triangle is the sum of the opposite two interior angles. Hence psi is equal to theta plus phi. So dy by d theta by dx by d theta is equal to tan of theta plus phi. Now this implies f of theta into cos theta plus f dash of theta into sin theta by minus f of theta into sin theta plus f dash of theta into cos theta, and RHS is tan of theta plus phi. So by making use of tan A plus tan B, we get it as tan theta plus tan phi by 1 minus tan theta into tan phi. Now divide both the numerator and denominator of the LHS by f dash of theta cos theta. So we get f of theta by f dash of theta, and cos theta get cancels, plus f dash of theta cancels, sin theta by cos theta is tan theta. So the numerator becomes f of theta by f dash of theta plus tan theta, and the denominator is minus f of theta by f dash of theta into tan theta plus 1, and which is equal to tan theta plus tan phi by 1 minus tan theta tan phi. Take the RHS as it is. Now comparing LHS and RHS, you see tan theta is equal to tan theta and tan phi is equal to f of theta by f dash of theta. Similarly, in the denominator also we get. Therefore, by comparing LHS and RHS, we have tan phi is equal to f of theta by f dash of theta. So consider this as equation 3. Since r is equal to f of theta, then dr by d theta is equal to f dash of theta. Now using this result in 3, we get tan phi is equal to r by dr by d theta. Thus, the angle between the radius vector and the tangent is given by tan phi is equal to r into d theta by dr. Hence the proof. Thank you.